Hello guys, welcome to my YouTube channel. In this video, I'm going to explain the remaining concepts in physical world. Before moving ahead with part 2, please make sure that you watch the part 1 of the physical world. That is where I am explained the basic of physics, scientific methods and the relationship between physics and technology, etc. So in this part 2 video, I am going to explain the forces in nature, basically focusing on fundamental forces in nature. So we studied the concept of force in our higher primary classes. So we know that force is needed to push, carry or throw an object or deform or break them. So in this video, we'll get quick understanding about the force that are naturally existing. So basically the force is defined as push or pull that can cause an object to change its velocity or shape. So when we look into this picture, first picture, what we can observe is initially the door is at rest. So if an object is at rest, that means velocity of the object is 0. So when we try to push or pull the door, what happens? Velocity gets increases. Now when we push or pull the door, the velocity is not equal to 0 because velocity must be greater than 0. Hence we can say that if we try to push or pull that door, then the velocity of the door gets increases. Similarly, if we consider the example of the rubber band and apply the force on either side of the rubber band in opposite direction, like in this direction as well as in this direction. So suppose this is F1 and this is F2, equal and opposite forces, that is F1 must be equal to F2. Then what will be the result? The length of the rubber band gets increases. So suppose initial length of the rubber band will be L and final length after pushing the rubber band, final length consider it as L1, then L1 must be greater than L. L1 must be greater than L. As a result, shape of the rubber band gets changed. Similarly, when we consider this example, third one, when we kick a ball which is at rest, initially suppose the ball is at rest, then if we kick the ball and then the ball starts moving with some velocity. So before applying the force, velocity of the ball is 0, and because that time ball is at rest, as the application of the force, the velocity of the ball increases. Then velocity must be greater than 0. So these are some examples of forces. There are two types of forces. First one is fundamental forces. So these are the forces which are naturally exist in the nature. So and they exist in the nature their own. There are four types of fundamental forces. First one is gravitational force, second one electromagnetic force, third one strong nuclear force, and last one weak nuclear force. So we are going to study in details in this chapter. And next, second type of force is derived forces. So these are the forces which are derived from the fundamental forces. So we have four types of fundamental forces, and derived forces are those forces which are derived from these four fundamental forces. If we think the example of derived forces, all other forces other than the fundamental forces comes under the derived forces. So some of the examples are frictional force, spring force and muscular force, etc. In this chapter, we are going to only focus on the forces that are naturally exist, that is fundamental forces. That is, we are going to study in details of gravitational force, electromagnetic force, strong nuclear force and weak nuclear force one by one. So the first one among the fundamental force is gravitational force. So initially, when we think of gravitational force, what comes in your mind? Obviously, an apple is falling down from the tree, right? Apple has made its own image in gravitational force concept. And gravitational force is a universal force. So what do you mean by universal force? It means that the force is applicable. The force is applicable for every object in every place of the universe. So if the force is applicable for every object at every place of the universe, then such forces are known as universal force. Because the gravitational force is applicable for every object in every place of the universe, so the gravitational force is known as universal force. So every object on the earth experiences this force due to every other object in the universe. So gravitational force is defined as the force of mutual attraction between two objects by virtue of their masses. So regardless whatever the mass of the two object is, gravitational force is a force of mutual attraction between those two objects. So all objects on this earth experiences the force of gravity due to the earth, motion of the earth, planet around the sun, and of course the motion of the bodies falling from the earth. So imagine this scenario: one boy is playing with the ball, and when he throw the ball in the upward direction, obviously the ball reaches to some maximum height, and due to gravitational force it comes back to the ground. So this is one of the example for gravitational force. Among the four fundamental forces, gravitational force is the weakest force. Force is the weakest force among the fundamental force. So gravitational force is the weakest force among the four fundamental forces, that are gravitational force, electromagnetic force, strong nuclear force and weak nuclear force. So moving to the second fundamental force, that is electromagnetic force. So from the name itself we can guess that this is the force something about electric and magnetic. So electromagnetic force is the force between charged particles. So electromagnetic force is the force between charged particles. So these charged particle can be either positively charged or negatively charged. Whatever it may be, charged particle that indicates that the particle is either positively charged or negatively charged, which implies that the force can be attractive or repulsive. So what do you mean by attractive and repulsive? So if the force existing between two equal charges, that is two like charges, force between two like charges are always repulsive, and force between two unlike charges are always attractive. So this indicates that the forces can be either attractive or repulsive. That is, if the force acting between like charges, then we say that the force is repulsive force, and if the force acting between two unlike charges, either positive or negative negative, then the force is repulsive, and for opposite charges the force is attractive. So this force doesn't need any medium. And this force is 10 to the power 38 times stronger than that of gravitational force. So electromagnetic force is stronger than the gravitational force. So moving on to the third force, that is strong nuclear force. The name of the force itself has the word strong, right? Which indicates that this is the strongest force among the fundamental force. So which is the weakest force? Weakest force is gravitational force, and strongest force is strong nuclear force. So this is the strongest force among the fundamental forces. Also, the name has the word nucleus because this force exerts within the nucleus. The nucleus contains proton and neutron, right? Hence, it is clear that if the force acting inside the nucleus, then it must be acting between proton and neutron. So, proton is positively charged and neutron does not have any charge. This implies that this force is charge independent. Because this force acts between proton and neutron. Proton is positively charged and neutron doesn't have any charge. So this implies that this force is charge independent. That is, it doesn't matter whether it is positively charged or negatively charged. So this is for strong nuclear force. And the last one is weak nuclear force. This is also a nuclear force, and this also exists within the nucleus, but this is very weak force, and this force comes into picture when we talk about phenomenon called radioactive decay. So weak nuclear force comes into picture when we talk about the phenomena called radioactive decay. So radioactivity is the phenomena which takes place only in heavy nuclei. So I am not going to explain in details because you are going to study radioactivity in details in future. So this is a weak force which exists inside the nucleus. This is also a nuclear force, and this also exists within the nucleus. But what is the difference between strong nuclear force and weak nuclear force is, weak nuclear force is weak compared to the strong nuclear force. So far we studied 4 types of fundamental force. So this is about 4 types of fundamental forces. Among these 4 types of fundamental forces, there are 2 forces which operates at very short distances, and there are 2 forces which operates at long range, that is large distances. So we have to make the difference which of these 2 forces are short range and which are the forces which acts on large distance. So First we will differentiate which are the short distance. So whether gravitational force is short distance, gravitational force that acts between Earth and Moon, right? So this can't be a short distance. So there are two forces which operates within the nucleus. These two, strong nuclear force and weak nuclear forces are the two forces which acts within the nucleus, and nucleus has very small diameter, that is very tiny, and that is where these two forces are also named as short distance forces, and the gravitational force and electromagnetic force act along quite a large distance compared to strong nuclear force and weak nuclear force. Hence, these forces are termed as long range force, where this is short range forces. So this is all about short range force and long range. So this is all about physical world. So thank you.